Hello everyone, in this video I'll be explaining the hardware setup that we created for this project. Now the pulse sensor is the corresponding wires. The middle one is the 5-volt wire, the grey one is the ground wire, and the black one is the signal wire, which is connected to the Arduino board via the breadboard to A0 slot of the Arduino board. Now as you can see, that is the white wire over here. And now coming back to the temperature sensor, here we have connected it. Basically the red wire corresponds to the ground wire, the orange wire corresponds to the 5-volt wire, and the brown one corresponds to the analog pin, which is connected via the breadboard to A2 slot on the Arduino board. Now the other connections that are coming to the LEDs, the middle LEDs corresponding to the temperature sensor, we have basically connected them to digital pins 843 in RGB order, that is over here. And similarly on the LEDs on the right corresponding to the pulse sensor, we have connected to the respective pins 7, 12 and 2 in RGB order in red, green, blue order on the Arduino board. And the buzzer that is over here on the right over here. Over here the buzzer is connected to the analog the digital pin 11 on the Arduino board, and we have basically created common ground connections as you can see here and here. And yeah, this is the hardware setup. And in order to increase the accuracy of the LM35 sensor, we have just additionally connected a 47 microfarad capacitor, polarized capacitor, between the voltage 5 volt voltage slot and the ground voltage that is across the temperature sensor. Thank you. This is just demonstration. If the parameters basically fall below the safety range, like for the heartbeat, if it falls below 60 bpm, and for the temperature, if it falls below that is 35 degrees Celsius. Now as you can see, just to demonstrate this, since we cannot achieve such extreme values for this, I've just given predefined values for this one, as temperature as 20 degrees Celsius and ppm as well as 20 degrees Celsius in the code, so you'll be seeing only those values constant. And as you can see, first it starts with the temperature sensor, blue LED plus a small beep, and blue LED for the heartbeat as well, and as beep. Buzzer beeps first, and then the LED, then the buzzer again, and the LED. Thank you. Now as you can see, I have kept my finger on the temperature sensor and on the heartbeat sensor, and since they are in the normal range, the LEDs you can see as they blink up. And if I do not replace my finger after each contact on the heartbeat sensor, you do not see a LED blinking, and the beep that you have heard is just that sometimes it gets out of the range. And as you can see, the temperature sensor, my temperature is fine, and as well as the heartbeat. And on the serial monitor, if you see the values right now, as you can see the ranges, we have kept it both in Celsius and Fahrenheit, and also the heartbeat. And sometimes it just gets out of range, that is nothing to worry, that's just 1 in 20 or 30 readings. Thank you. Now in this video again, we have set extreme values in the code. Since we can't attain extreme values, I have just given predefined values, that is 45 degrees as temperature in Celsius and heartbeat to be 120 degrees. So it doesn't have to be taken from these sensors, as you can see. Now starting from a long beep, and then a red LED glows up, and again long beep, the red LED glows up again. Now we have also produced a different tone compared to when the parameters fall below the safety range, and these are the ones which are higher than the safety range. So the buzzer, when it is higher out of the safety range, that is the temperature and BPM are higher than the normal range, it would produce a longer beep compared to the case when we have ranges when we have ranges which are below the safety range, we have a smaller beep, as in the other video as shown.
And in this clip, we are showing a time lapse of the code explanation done by our teammate Nitin Teja Machadla. And yeah, thank you.